Most people are convinced that robots are the future, a future that's still a long way off. But here's something few people realize. A device already exists today that can work for the kind of sum a person spends on a cup of coffee per hour. If the calculations are right, one such robot could end up cheaper than hiring someone on minimum wage. The question isn't whether this will happen. The question is whether we're ready for what comes next. We're talking about Tesla Optimus, a humanoid robot that has already gone through 4 major generations and is currently on version 2.5. But it's the next version, Optimus 3, expected to be unveiled in August. That could be the turning point after which talk of robots of the future finally becomes a thing of the past. Elon Musk has already said something unexpected. When people see Optimus 3, they'll get the feeling there's a person in a suit inside the robot. That, according to him, was the intention from the very start. This isn't a marketing trick. There's concrete engineering logic behind it, which we'll come to shortly. First, let's look at why Optimus 3 is considered such a watershed. It's the first version to feature the Grok voice interface, the AI-5 chip, a 4680 battery, and a whole range of other technologies that Tesla has kept under the tightest secrecy until now. Musk explained the reason for this secrecy quite plainly. Revealing details too early creates a risk of copying. That's why most of Optimus 3's specifications remain officially unconfirmed to this day. At the same time, Tesla is restructuring itself. The Model S and Model X production lines at the Fremont factory have been halted. The freed-up space is being given over to Optimus Gen 3 production. A second production facility at the Texas Gigafactory is also being prepared for launch, with planned capacity of up to 10 million units a year. The company everyone once knew as a car manufacturer now officially calls itself a physical artificial intelligence company. And judging by its actions, this is more than just words. Now let's turn to what actually sets Optimus apart from everything we've seen before. Compared with Chinese humanoid robots, Optimus looks slower and less acrobatic. Chinese developments can run, jump, and perform impressive movements, but here a fundamental question arises. Can such a robot wash a plate, open a bottle of water, or pick up an egg without crushing it? Tesla is deliberately heading in a different direction. Nobody's going to pay for a robot that can dance but can't do anything useful around the house. That's why hands become the key element of Optimus 3. Each new hand will get 22 degrees of freedom, roughly twice as many as the previous generation. The number of internal sensors will grow almost threefold, allowing the robot to recognize textures, shapes, and objects with a fundamentally different level of precision. According to available information, the new hands may get waterproofing, which substantially widens the range of tasks Optimus is capable of handling. Tesla has also changed the very architecture of the hand. Most of the actuators have been moved into the forearm, with finger control carried out via bio-inspired tendon cables running through the wrist. This precisely mirrors how muscles and tendons work in the human hand. Instead of cramming motors into a tiny palm, Tesla places the muscles higher up and transmits the force down to each finger individually. The result is a lighter, more compact, and more precise hand. Based on the expected specifications, Optimus 3 will be able to lift a crate weighing around 18 kilograms, and at the same time, thanks to the sensors, it will be able to carefully pick up a fragile object, such as an egg or a battery cell, without damaging it. Musk has openly admitted that the Optimus hand will be extremely expensive to manufacture. High-power actuators tend to be heavy and imprecise. Small, precise ones aren't strong enough. Tesla, it seems, has found a way to solve both problems at once. Now let's turn to the AI-5 chip. This is Tesla's most advanced chip to date, which has only just entered pilot production. For comparison, even the Cybercab robotaxi runs on AI-4. The fact that Optimus 3 will get AI-5 says a great deal about the company's real priorities. This chip is meant to move Optimus out of the category of robots that follow pre-programmed movements and into the category of machines capable of seeing what's happening around them, reacting to changes, and making decisions in real time. AI-5 will also provide significantly higher memory bandwidth compared with AI-4. For a robot that needs to process huge volumes of data with minimal latency, this is critically important. There's a fundamental difference here from a self-driving car. A self-driving car needs visual intelligence. Optimus needs both visual and physical intelligence at once. The robot has to understand what it's looking at, where to pick up an object, with how much force, and how to adjust its movement if something goes wrong, and all of this without pauses or freezing up. Musk has also confirmed that Optimus 3 will initially work inside Tesla's factories, observing employees, copying their actions, making mistakes, and gathering data. But the most interesting part is the learning mechanism. At a meeting with investors, Musk mentioned that Optimus will be able to learn by watching videos on the internet, including instructional videos on cooking, cleaning, or working with tools, without needing to have every single action programmed in by hand. And here, another important principle comes into play. Whatever one robot learns can be passed on to the entire fleet through a software update. If one Optimus has mastered cleaning, millions of others can acquire that skill almost instantly. This is Tesla's main competitive advantage, not just a robot, but a system that learns collectively. Now to the question of cost. Musk has cited $30,000 as a benchmark figure, but the first commercial versions are likely to be more expensive, perhaps $50,000 or more. Even so, the sums involved are interesting. If a robot works 20 hours a day, 350 days a year, over 10 years, that's 70,000 working hours. At a price of $30,000, the cost per hour works out at around 43 cents. Add in electricity costs, and the total cost per hour of operation comes to around $1. This isn't fantasy, it's simple arithmetic. But Tesla still has three key problems to solve. The first is development speed. The second is safety. Optimus is heavy enough that an accidental movement could injure a person, which is why the direct route into people's homes remains closed until large-scale factory testing has been completed. The third is manufacturing. Almost every component of Optimus is being built from scratch. Joints, actuators, control boards, fingers. All of this requires new supply chains that don't yet exist. Tesla is effectively building an entire industry from the ground up. If the company manages to solve all three challenges, developing quickly, ensuring safety, and setting up affordable mass production, Optimus will stop being a demonstration stand. It will become a device that transforms the labor market, domestic life, and industry all at once. Some professions will disappear, but new ones will emerge too. Perhaps ones we don't even think about today. How do you feel about humanoid robots? Are you ready for the possibility that within just a few years, such a robot could be in your own home? Share your thoughts in the comments. It's genuinely interesting to discuss. If this video got you thinking, hit like and subscribe to the channel. The next episode could turn out to be even more surprising.